In this video, we're going to look at a common quadratic equation math problem. We're going to be given 3 points, and we're going to be asked to solve for the quadratic equation, basically solving for A, B, and C. We're going to do this all mathematically and not graphically, but I'm going to show you a graph to show that it does work. And in a future video, we can take a look at this graphically and how do you graph when you're given 3 points. And so we're going to take a look at one simple example problem, and then I'll give you a second problem, ask you to pause the video, work on your own, and then we'll solve it together. All right, so now let's take a look at what we're actually going to be given in the example problem. And I'll walk through the steps at a high level, and then we'll walk through the steps in each example problem together. All right, so you're going to be given 3 points. X1, Y1, X2, Y2, and X3, Y3. They're going to lie on the parabolic curve, but you're not going to be given the curve, obviously, right? And we're going to be asked to identify the quadratic equation. So this quadratic equation will define this parabolic curve, and the 3 points will lie on it. Pretty straightforward. So essentially what we're asked to do is solve for the unknowns A, B, and C. So you have 3 unknowns, you're given 3 points, so we need to build 3 equations to help us solve for these unknowns. Right? So first, we're going to plug in each of these into the general quadratic equation. So that'll give us 3 equations. So for example, I plug in y1 for y and x1 for my x terms. So I get the first equation as y1 equals a x1 squared plus b1 times x1 plus c. So y1 and x1 in this case are given values, right? There's a number associated with it. In the general form, x and y are variables. A, b, and c are actual constant values. So that's a difference. I know sometimes it can be confusing in just a variable form, but you have to remember when we have subscripts, they actually represent numbers. When there is no subscripts for x and y, they represent variables. So you do the same thing for point 2 and point 3. So now we have 3 equations and 3 unknowns, A, B, and C. So there's a lot of different ways to go about it. I see the C's right here have the same constant 1 in front of them, right? So because it's a constant. So that's the easiest one. Either you can substitute, or what I like to do is just subtract equations. So it doesn't really matter which pair you subtract. I'll choose 2 and 1 and 3 and 1. You could choose 2 and 3 and 3 and 1. It really doesn't matter. So the purpose is to drop out the C term. Once you do that, you're going to be left with only the unknowns A and B in this new set of 2 equations. Then you can solve for A and B. I'll walk through that process. It's basic algebra. Once you find A and B, you can plug it into either equation 1, 2, or 3, and then you can solve for the last unknown, C. So we'll walk through an example problem with this exact process. We'll start off with a very basic one to show you how this is done. In this first example problem, we're going to be giving you the final answer, y equals x squared. Right? So we already know what our constants A, B, and C in our quadratic equation will be, but we're going to give you this context so in the back of your mind, you know what you're trying to solve for. We'll also give you the graph of y equals x squared so you have something to reference. In the next problem, we won't give it to you. We'll just give you the 3 points, and we'll walk through that process together. So my final equation is y equals x squared. I'm going to give us 3 random points on this curve, right? So I have -1, 1, which is right here, 2, 4, which is right here, and -3, 9, right here. So remember, the first step is to write out 3 equations. So all we need to do is plug in, remember this is x, y points, and we just need to plug into our general quadratic equation. So for equation 1, I'll have y is 1, y1 is 1, a times -1 squared, my x1 term squared, plus b times -1, that's my x1 term, plus c. And then I could rewrite this a little cleaner. 1 is equal to A minus B plus C. Okay? Now we can do the same thing for equation 2 using point 2. And we have 4 as y2. A times x2 squared is 4a. 2 times b plus c. And then again for equation 3. Equation 3, I get y3 is 9. Negative 3 squared times a, so 9a. Negative 3 times b, so negative 3b plus c. Right? So that's step 1, just setting up the 3 equations. Step 2, we subtract 2 pairs of these equations to drop out our c term. So I'm going to say, let's see, equation 2 minus equation 1. This will give me, and I'll call this equation 4. I have 4 minus 1 is equal to 3. 4a minus a, that gives me 3a. 2b minus negative b is 2 plus 1 times b, so 3b. And then c minus c gives me, or I don't have a c term, right? So that's my new equation 4. We'll do the same thing for, let's say, equation 3 and equation 2. Remember, it doesn't matter which pair. I can do equation 3 minus equation 1 here if I like as well. It doesn't matter, but I'll call this one equation 5, right? So 9 minus 1 gives me 8. 9a minus a gives me 8a. Negative 3b minus negative b gives me negative 2b. And then c minus c gives me 0. Right? So these are my 2 new equations. Now the next step here is to isolate one of them so I can plug it in. So either A or B, doesn't really matter. So let's see. Let me solve for B using equation 5. So I can say that this is equal. I can say B is equal to, if I move 2B over here, move the 8 over there, and then divide by 2, I get what? 4A and then minus 4. Okay? So what I'll do now is I'll say equation 5 plug into equation 4, right? So I'm going to plug the b term into this equation so I can solve for a. So I'll get is 3 is equal to 3a plus 3 times my new b term, which is coming from equation 5, 4a minus 4. Okay, so now I just have my unknown a in this equation, and I can solve for it. So I get 3 equals 3a, distribute the 3, it gets 12a minus 12. And this is what? This says if I move 12 over to the left side, I get 15. And then 3a plus 12a is 15a. So we know that a is equal to 1, which is good because that's what's expected. All right, we're not done yet. We need to solve for B and solve for C and make sure that they both equal 0. So the next step I would do is either use equation 4 or 5. It doesn't matter because both equations 4 and 5 have just A and B terms. So we can solve for B now. Plug in A equals 1 into, let's say, maybe equation 5, because it's all set up already to solve for B. So equation 5. And that will give me B is equal to 4 times 1 minus 4, right? Because that's my A term, is equal to 0. So B is equal to 0, which is what we expect as well, because there's no linear x term in my final equation. Now finally, we have to plug in both A and B into either equations 1, 2, or 3 to solve for C. right? So last step, let's do it over here. Plug in A equals 1 and B equals 0. Let's do it to equation 1. To equation 1. All right, so we'll get 1 is equal to A, which is 1, minus B, which is 0, plus C. So we can see clearly there, C is equal to 0. And all of that checks out, right? So pretty standard process. We could give you any set of 3 points, and we could solve for A, B, and C in the same way to figure out what quadratic equation crosses through. So we're going to look at a little bit more complicated, interesting problem where B and C are not equal to 0. And I won't give you the final equation, and see if you can work through it on your own. And then you can unpause the video and see if you match the process or the final answer. Right? There's a lot of different ways to solve 3 equations, 3 unknowns. This is just one method that I think falls out nicely because the C terms all have the same constant in the first 3 equations. So let's take a look at our next example problem. All right, so in this example problem, we're going to do the same thing we did in the previous one, but instead of giving you the final equation and the graph, I'm only going to give you the 3 points. So I'm giving you -6 and 8, that's right here, -1 and 10.5, that's right here, and 1 and 4.5, that's right there. So I want you to see if you can visualize what parabolic graph or line falls on each of these 3, has these 3 points in common, and then solve it by setting up the 3 equations and solving for A, B, and C in any way you feel comfortable. Then pause this video, go through the solving process, and then come back to see if you can match the final answer that I get. And if not, you can walk through the process with me as I solve it now. All right, so go ahead and try to solve this on your own. Okay. So hopefully you had a chance to work through the problem. I'm going to walk through it with you now. So I'm going to do it a little quicker. So equation 1, I'm going to set up with 8 as my y1 and 36 for my x1 squared times a. And then b times x is b times -6, so -6b plus c. Do the same thing for equation 2. We have y is 10.5. -1 squared is +1, so we got a, negative b, plus c. Then equation 3, we have 4.5. We have 1 squared, which is just 1, times a, plus b, plus c. Okay, so we have our 3 equations. Hopefully you matched that as well. And then we can subtract any 2 pairs. I'm going to use equation 2 minus equation 1, right? These 2 right here. And I'm going to define this as equation 4. And this is going to give me 10.5 minus 8 as 2.5. 1a minus 36a. This gives me negative 35a. Negative 1b minus negative 6b. This will give me plus 5b. And then minus c. C minus c. So those cancel out. Then I'll choose equation 2 minus equation 3. And again, it doesn't matter which pair you choose. This one nicely follows out a simple variable, or one of the parameters that we're trying to solve for. All right, so I got 10.5 minus 4.5. This gives me 6. 1a minus a, that gives me, all right, the a's drop out. And then minus b minus positive 1b, that gives me negative 2b, and then the c terms drop out. All right, so this one nicely gives me my b constant value. So b is equal to negative 3. Okay, so hopefully you got that as well. Then we can plug in b as negative 3 from equation 5 into equation 4, so we can isolate our constant a. To equation 4, let me change colors for now. All right, so then this gives me equation 4, 2.5 is equal to negative 35a plus 5 times b, which is negative 3. So 5 times negative 3 is negative 15. Okay, still with me? All right, so then I can move the negative 15 over to the left side. 15 plus 2.5 gives me 17.5 is equal to negative 35a. So we can see that a is negative 1/2. All right, very good. We're almost done. So the last step is to plug in the b and a values into any equation, either 1, 2, or 3. So then plug in b is negative 3 and a is negative 1/2. And you can choose. In fact, once you solve for a, b, and c, you can plug it into the other two equations, 1, 2, or 3, and check that you did it correctly, because a, b, and c should work for all of the equations. If it doesn't, then you did something wrong in the calculation. So we got plug it into, and I will choose equation 3. Right? So equation 3, I have 4.5 equals a plus b plus c. So a is negative 1/2, b is negative 3, and I'm solving for c. So negative 3.5 plus c. So this gives me 4.5 plus 3.5, which is 8. So c is equal to 8. So my final equation, y is equal to a, which is negative 1/2. Oops. This should be negative 1/2 times x squared, right? Because that's my a times x squared plus bx, so negative 3x plus c, which is 8. So this is the final equation I got. What did you get? Let's see if this matches the true solution. So this is the shape of the curve. And we'll see in future videos when we explore the behavior of graphs related to a, b, and c parameters. This does represent a negative a term, and it does match my final equation. So great. Hopefully you got it. If you didn't, go through your work and see if you made an algebraic error or if you plugged in values wrong at the start in equations 1, 2, or 3. So do some more different kinds of example problems in future videos.